research support, we can find the molecular biology facility here. And go down, you can see the clone and the vector collection. Ordering, we can see go to CVT. This is fly. And next we can go to the fly base to search the gene IMP. And we can see the molecular stock and the reagents. From here we can find the CDN clones if we can find the CDN clone 4 clones. You can see here some of these clones is in full length, but some are only the fragment. So we have to align to see which is full length, which is fragment. To search a gene, you can try to search first. It's a gene name IMP. Okay, we can find the three clones here. So now we need to align. Okay, so go back to this gene. You can click find the CDS. There are so many ice form. Because I have so many ice forms, so it's not easy to determine which one we should use to align. You can see here. But for most of the ice forms, they are very similar at the coding region, not the UTR. You can see here RA and RB is similar. RA and you can see here. Where is RC? Okay, so the first clone we get a sequence here. Oh no. Clone ID SD07045. Okay, go back to our reagent. SD. This is the first clone. Library. Prepared. Okay, we try to align this sequence from the. We can go to back to the home page. Okay, home page, blast, and nucleotide to nucleotide. We can choose which one. Okay, forget this. We just use NC vector NTI. DNA moleculars. First is IMP and copy the sequence. Okay. Another one, DNA IMP. Back to the GM. This one. Oh, this one is very short. Oh, but the last one, IE. this is very long. Replaced. Usually if the cDNA is replaced, it might be some mutation. Okay, go to back CDS. RP is same. Okay. C file C file C. Go back to the database. DNA IMP. Switch. Align. Selected molecules. We can submit. Oh. Something wrong with here. Okay, close it. Close it. Open again sometimes. Open here. Search IMP. Line. Submit. Okay. This clone has 2-point mutation here. Okay, let's perform the translation to say, you see she has the same protein sequence. RA copy, translate, forward, translate. This is the first one. Or we can use online tools. Here. IMP PI. Okay, let's get the clone sequence. SD. Translation. Translate. Okay, we have 3 different reading frame. This longest one looks the same, the right one. Okay, so we can name it as SD. Okay, submit. Okay, perfect 100% match. So this amino acid mutation does not affect the sequence of the protein. So it's very good. We can order this clone SD and add to cart, and can use your name as in lab. Okay, and finally you can continue ordering. Finally, after you order all of the clones, and you can complete the order. So next we need to find the cutting site, enzyme site of this one. Okay, close this. Now we know that this sequence is the clone we will be used to. So first we need to go back to check the vector information of the UASZ. UASZ 1.0. So we can go to another site, biology, Drosophila reagent page. Yeah, Drosophila Genomics Resource Center. We can search UASZ 1.0. Here you can find the vector information file. Here it's a sequence file. You can download into your vector NTI. A note here. Okay, let's go back to find this paper out. Our reference. This is where is it? Efficient expression of gene. You can go to the link, open link of this paper. Now you can find the supplementary information. Okay, go to this link. Okay, download. We can see the multiple cloning site here of this vector. It's UASZ from BAMH1, XHO1, KPN1, SPE1, XBAR1. These are the cloning sites we can use to perform the double digestion. Okay, you can see the cutting site configuration list. You can go back to remove all unnecessary and put all what we want here. The first is BAMH1, XHO1, KPN1, XHO1, KPN1, and SPE1. SPE1, XBAR1. Okay, put them here. Okay, and run. You will find all of this cutting site is here. It's located very close. Actually, this is not very good. That's the weakness of this vector. That means they didn't design it very well. Because usually for the cutting side, we need some gap here. Because if it's too close, can cut x bar 1, x whole 1. So suggest that this 3 is good. Or you can use the SPE x whole 1. Don't use the 2 very close. For example, damage 1 and x whole 1. These too close. So sometimes if one enzyme is cut, it might affect the efficiency of the another enzyme. Not always, it might be. So first determine which enzyme we should use. This is the vector sequence. No, the clone we ordered the sequence, but this is not what we should clone into because it's containing the UTR sequence. We need the CDS. CDS we can see here. And it's a ATG. Where is the ATG? I can see 270. Start from 270. CDS. We first can check damage 1, x bar 1. Damage 1, x bar 1, they are far away from each other. See the sequence is vector. It's containing one damage 1. Oh, not here. See the list. Move on. Damage 1. X bar 1. Run. So it shows that the sequence does not contain damage 1 x or not x bar. Let's do it again. X home and X bar 1. Does not contain all of them, so that means any of these sequences can be used for the cloning. Okay, so now we can recording what we are doing here. So first name this gene IMP forward sequence. Can see enzyme used IMP reverse. For example, we can choose two of them. The first is BAMH1 is GGATCC. Here X bar 1 TCTAGA. Before the enzyme sequence, we need to add some protector and protect the base. Usually the general GAGA works very well for most of the enzyme. GAGA. Okay, following the enzyme kiting site, the first one, the forward sequence, we usually add some more sequence. 1 second. Enzyme BAMH1 is X bar 1. X bar 1. Where is X whole 1? No, X1, no good. Yeah, X bar 1. BAMH1, X bar 1. BAMH1, X bar 1. We can see the CACC. What's the function of CACC? It's a Kozak correct. So correction. This is a function of Kozak. Actually, fly is a CAAA. It's good. ATG, you can see here. So we can paste, we can add the CAAA here. It. So the next is the sequence of the IMP from the ATG. So usually about 20. First you can choose a little bit more, for example 30 base pair, and copy it. So next go back to the TM calculator. Here is the NEBQ5. This is the enzyme. This is the PCR enzyme we are going to use next. So primer 1, we can see here the CG and the TM. Usually we can delete this sequence to match the TM to around 65. For example, okay, 2363 is okay too. So for the reverse sequence, go back to here. TAA is the terminal amino acids. We can also copy 30, but here you need to use copy of the reverse complement. Okay, so go back to here. We also perform the deletion 28, 27, 26, 28, 4, 23, 22, 21, 20. Okay, 19. But make sure no shorter than 18. Yeah, if too short, it works not good. So if so here we can choose a new temperature. It's 64 degree. But usually it doesn't matter if two or a little bit difference. So we copy this sequence here. CAAA, we can mark it. TAA. So here is the information of this enzyme. If you design this, when you got the primer, and you can use this primer and use the vector, the plasmid you ordered from the downstairs, this one, as template. Once you got this plate, you don't have to extract the plasmid. You just use the clone, the bacteria. You can use 100 microliter DD water to dilute this bacteria and use 1 microliter as template, and then use this primer, and also use the PCR enzyme is Q5 2x mix and perform the PCR, and then cut the band. How about the size of IMP? We can see here it's about 1,700 base pair. It's about 1,001 base pair. So you can also mark down the function of this prime is to use to generate pUASZ1.0 and IMP. You can also to show this is a sequence of RA. So once you got the PCR product, you can purify it, cut the gel, and then perform the digestion with BAM-H1 and XBAR1. So you can find the information of this enzyme also from the NEB New England Biolab website. For example, you can try to search BAM-H1. They have HF. HF is a high fidelity. It's much better than BAM-H1. We have most of this enzyme. If we don't have, you can search from the cube. Otherwise, you can order from the purchase. BAM-H1, we can see here. Okay, another thing is we need to find the double digestion enzyme. The buffer which we used, you can remember the website, or you can search from the Google. The first one is BAM-H1HF, The second one is X bar 1. We can see here the cut smart works good for both of them. So for you need to BAM H1 HF X bar 1 and perform the double digestion at 37 degree. So the buffer is cut smart. Okay, after the digestion, you can use a CIP enzyme. CIP. To treat your vector. But remember, don't treat your DNA, your IMP PCR product. Just treat the vector. This can reduce the negative clones. It's good for your selection. So for the next is where everything is similar with what you previously did. So just check your notebook. So here is an example how to order the clone and how to design the cDNA. Sometimes the Star Wars doesn't have every, for example, doesn't have all of the clone. If you cannot find the correct clone here, you can go to the DGRC. The DGRC is here, Drosophila Genomics Resource Center. You can search the product here. For example, if we find your clone, some clone in the name ID of the clone, you just search the clone here. You can see the clone is here. And then you can order this clone from institute. So how to order the clone from the institute? Oh, 1 second. PC. It doesn't matter. Stack number. Remember the stack number. Here I will show you how to order the vector plasmid from the DGRC. Okay, so we go to the purchasing system. We can search the new request and enter in the stock number here. So search a vendor. So what is the vendor of DGRC? We can see here is Indiana University. So you can search from here in Indiana University. It's here. Just search. So if you couldn't find anything, just enter non-catalog item request. So here is Indiana University, and this is the stock number, and this is mail. Maybe you can use while. You can use while, and the quantity one price. You can see 43, and the item description. What's this? You can or you can copy the information here. SD7, for example, IMP cDNA catalog is here. Okay, just click the OK in the University. Just click OK. It will be in your shopping cart. Just finish, and it will purchase and deliver this vector to you. Once you get this vector, you just add the 100 microliter DD water to the vial and quickly to mix it well. The white pellet is actually the paper. The plasmid is on the paper. So you just mix well and use 1 microliter and transfect this 1 microliter plasmid into the DH5 alpha, the competent cells, and finally you will got your clone, or you can just use this as template too. But remember, you can get the information of the vector here. So we can see the vector is POT2. The antibiotic selection is here. We also have this antibiotic. You can find it in the -30. Okay, so that's all. This is an example how to make this. Okay.